Alright, today we're going to talk about quadratics. So far, we've only dealt with linear equations, right? Y equals 5x minus 2, for example, where we only have one x and we have one y. Well, today we're going to introduce a different type of equation that we're going to talk a lot more about in the next coming videos. And this is the quadratic. And the quadratic is different from linear equations in that we have more than one x. Well, what do I mean by that? Well, this right here would be a linear equation. But something like this would be a quadratic equation. You might see right away, hey, we have more than one x. We have this x squared term out of nowhere, right? What is x squared? That's basically x times x. And we call that double multiplication a square. We're going to talk a lot more about that in some later videos. But for now, just know that basically whenever we have a number in here, we're multiplying it by itself, right? So we have this quadratic here. You might say, okay, why do I really care about this? Well, just like linear equations had a lot of interesting properties. We could solve for them algebraically in different ways. And when we graphed them, we had some pretty interesting phenomena. We had parallel lines and perpendicular lines. We have a lot of other interesting stuff, completely different stuff, but interesting stuff with quadratics that it's important to know. But first, just like we had with lines, we had the slope-intercept form. With quadratics, we have the standard form. And that kind of defines what it means to write and represent a quadratic. So, the core components of a quadratic are pretty simple. ax squared plus bx plus c. Right? A, b, and c are all known values, and a can't be 0 because we have to have this x squared term in here. X is the variable, or the unknown. And oftentimes, and in fact most times when you're dealing with quadratics, they're going to be set equal to 0. Right? So in this case, we're not going to really have much of a y to worry about, but we're going to have a 0 to worry about. So it's important to know that we can represent these quadratics in other ways too that might be hidden from the standard form. For example, something like this. X squared minus 3x plus 1. In this case, we don't have an a because our a is just 1. Instead of writing 1x squared, we just write x squared. Likewise, we can have equations like this. Let's say z, this is my variable, times z minus 1 equals 3. And if I write it out, in simplest form, do my distributive property, z squared minus z minus 3 equals 0. And that also confines to my standard formula. So just know, anytime you see a function that may not have this perfect standard formula of a quadratic, it can still be a quadratic. It is a quadratic as long as it has that x squared in it. That x squared and no more than that. X squared, defining characteristic of a quadratic. The highest term you'll have is an x squared, or x times x. Now, just like linear equations, we can also solve quadratics. And there are a variety of strategies we can do to solve quadratics. Because you noticed, right? We set this quadratic equal to 0. So you might be able to say, well, we should be able to solve this. It's an equation. We have one variable, and then we have a number. We should be able to solve for x. And we're right. We are able to solve for x. And this is the most crucial thing you can do with quadratics, solving them. In the next couple of videos, we're going to look at how to solve quadratics, to find out what x equals for any given quadratic. That will be our quest. So, this has been an introduction to quadratics. Just as a quick summary, quadratics are like linear equations, except we have an added x squared term onto them. That's all I have. I hope this video helped, and I hope you have a great day.